Hey, this is MAT 221, Calculus 1. This is section 3.2 dealing with the product and quotient rule. This is video number 2. So we just talked about finding the derivative numerically. If we're given numerical information, we could take the derivative and then find the derivative using that numerical information. Now I want to try to do a couple of examples with the quotient rule. So let's look at a couple of quotient rules here. Let's do number 1. If we put the rule in here, we have a function divided by a function. And the rule for the quotient rule is low, or the denominator, don't do anything to it, times the derivative of the numerator, which is low d high, minus high, 1 minus x, d low, the derivative of the denominator, over the denominator squared. Now here we would leave the denominator as a unfoiled binomial, but the numerator can be simplified by combining like terms and simplify it. So I simplified it by combining like two terms and doing a little algebra, distributing the -1, foiling this expression, and then distributing the -1. For problem number 2, it might be better to, instead of having to use the quotient rule on the first expression, because this is a monomial denominator, it's sometimes easier to just bring it up as a negative exponent and then use the product rule. It's a little bit easier than having to use the quotient rule with the product rule here. So I rewrote the function first, and then I'm going to take the derivative. The derivative said the derivative of the first times the derivative of the second, plus the second times the derivative of the first. All right, so this ends section 3.2, but I wanted to look at some, sorry about that, this is the comic that goes to for the end of section 3.2, but I wanted to look at the worksheet that's in the worksheets folder in Blackboard, saying a worksheet called the product and quotient rule. These are just some of the examples on there. All the other examples are actually up there for you to do, but I wanted to do a couple with you together. So what we're asked to do is differentiate using proper notation and simplify all your answers. In some cases, it might be advantageous to simplify or rewrite first. So let's look at number 1. Number 1 is definitely the product rule. It takes a function, multiplies it by a function. So let's take the derivative. The derivative of using the product rule would be the first times the derivative of the second, plus the second times the derivative of the first. Now, multiplying through here and doing a little bit of algebra, we get this, and then we can combine like terms. I have x to the 5/2 and x to the 5/2. This is 1, this is 1, this is a half, so that would also combine. My final answer would be 3x squared plus 3/2 x to the 5/2. Again, here's where the calculus is done. From this point forward is just simplification and algebra, and that can get quite complicated, which is one of the reasons why I had you do the limit definition of the derivative by hand so often in Unit 2. All right, let's look at this expression. I'm going to rewrite this expression as 2 over t as 2t to the -1, and then use the product rule here. So the product rule says the first, don't do anything to it, times the derivative of the second, plus the second, don't do anything to it, times the derivative of the first. Rewritten, this becomes -2t to the -2, plus 5t to the 4th. Now if I distribute, again, remember when I distribute, I multiply the coefficients, and then I keep the base and add their exponents. So when I do so, I get this expression. This becomes 6t to the 1st. This becomes 3t to the 7th. Foiling this, this becomes -2t to the 1st, then -2t to the -2. Then multiplying here, we get 5t to the 7th. and multiplying here, we get 5t to the fourth. Combining like terms, we have t to the first here, we have t to the first here, we have t to the seventh here, and t to the seventh here. So combining like terms, I get this expression. 4t to the first plus 8t to the seventh minus 2t to the negative 2 plus 5t to the fourth. I'm looking at number 3. Here we would use the quotient rule. We would say low d high, derivative of the numerator was 0, which is nice because this whole expression will now go to 0, minus high 1 times the derivative of the denominator d low, which is 3y cubed. Oops, I'm sorry, that should be y squared. Let me stop this and fix. All right, sorry about that. I had to fix my PowerPoint here. So this is the derivative of the denominator is 3y squared plus 2 over the denominator squared. This now goes away. The numerator now becomes just negative 3y squared plus 2 over that denominator squared. And then lastly, I thought I would do number 13, which is the product rule, but it has function notation in it here. So it's saying let y of x be z of x, some function, over the function 1 plus x squared. And it's asking you, if you know this information and this function, can you find the derivative of y when x equals negative 3? So what you would do here is use the quotient rule first. Now notice the quotient rule is low d high minus high d low over low squared. And in this case, we're using function notation for z because we don't know what the function is. Next, I would put in negative 3 for every place we see an x. When I do, I can then evaluate this and simplify this expression. Let me move this down a little bit for you. All right, so now you can see this bottom part here. So we look here, we would simplify this expression. So when I then now look at this expression and put in these values, I know negative 3 squared is 9, plus 1 is 10. Then I'm going to take z prime at negative 3, which was given to me as 15. I'm going to take z at negative 3, which is equal to 6. And then 2 times negative 3 is negative 6. And then again, putting in those values. So I get 10 times 15 minus 6 times negative 6 over 10 squared, which gives me 186 over 100, or 1.86. All right, so those are some of the examples from the worksheet. Work those other ones by yourself and then check your answers in the worksheet folder. Have a good week.